Hello, everybody. It's Mr. O'Shea, and we're going to be going over a Desmos activity called Dandy Candies. Instead, it's going to be 45 to 60 minutes, but I'm going to give you kind of a rundown about how this is going to be done. I'm going to go ahead and assign this to not the class. I'm going to give you a code. Oops, back, assign. Okay, click this one. Single session code. This will be available for 2 weeks, I guess. Why not? And your code is going to be VZ9S2H. And so let's go ahead and give you a link to that. You're going to go to student.desmos.com. Make sure there's no S here. Desmos with the plural S.com. Type in this code, sign in with Google, and you should be good to go. I will also go ahead and copy this link onto the Altitude. But let's go ahead and log in and view this dashboard and get started. Close out of that. Let's take a look at what you'd be doing if you were a student. So here is what it would be looking like. Let's watch this video real quick. It says, what's the first question that comes to your mind after watching this video? And it's not just like, what was that? I'm looking for more in-depth questions. So let's watch the video and talk about some questions that you may have. Hopefully you can hear the sound of it. So give me 1 second, make sure I can give you the sound. I don't know. Maybe we won't get the sound, but it has some nice music to it. So let's try it one more time. This is a candy, and it's wrapped in a box. All right, and the song was Pure Imagination from Willy Wonka. So what is a question that comes to your mind? One of the questions was, obviously it's like, what was that? But my question is, how many candies were there? Why were they moving around so much? What are some things that they were trying to do? Like, what are they trying to do? Those are the types of questions that we want to think about. All right, so you want to go ahead and type those questions in here, and we're going to go ahead and click next. Which one of these packages do you think uses the least cardboard? Okay, so cardboard is being used, and they give us 4 different dimensions, right? So they have A, B, C, and D, and so we got to figure out what uses the least. So this is in terms of like surface area. So when you think of surface area, you got to think about what it is. So there's, for example, here is a box, and then here is a cube, right? So surface area is everything on the outside of the box. So like it's the area around the box. However, when volume is everything inside, right? And that is going to be everything inside. So if I wanted to, like, say I filled this up with water, right? So the whole box is filled up with water, and that means that that's the volume inside. So volume is inside box. Volume is inside the box like water. And this one is going to be surface area, which is outside the box. Like, for example, wrapping. So like a food wrapper. Like a food wrapper or a box, gift box, gift box that is surrounding what's inside, okay? So volume is going to be more inside, and then the surface area is outside the box or around. So like around the box, okay? And sometimes it's also around the top and bottom too, so it's just around. All right, so let's clear this section off. Which one of these do you think uses the least? Now, I'm going to be completely oblivious. When I initially see this, this seems like that's a lot of cardboard because it's very long. All right, so I don't think that's it. Looking at this one, it's pretty long, but it's tall as well. This one here looks tall, wide, and it looks pretty good, but I think D looks like the smallest use of cardboard. And it could be I'm wrong because the length is not so much, but more so the width. But I'm going to say D. All right. So I'm going to say, and explain your thinking. And so you would write whatever you think. But if you think it's C, because you can probably say C is because it is very slender and narrow, but tall. B is in between that, and A is very long. So whatever you want to say. Here is package D. Perfect. I like package D. How much cardboard will it take to make this box? Okay, so the thing that we want to talk about here is surface area. So that means what is going to be the area of this? So this right here, let's just say it's 1. So 1 unit. So this is across here to here is 1, 2, 3, 4, 5, 6. So it's 6 across and 1 up. So that means this entire area is 6 units. Then this entire area right here, I should probably use a different color. Let's use green. This entire area is 4 units. And then it is basically 6 by 4. But there's also a 1 here because it's 1 unit high. So 6 units across, 1 unit up. So 6 units squared. This is 4 units squared. And then we have to think about, that's only 2 sides. There's 2 more sides. So then this side is another 4 squared, 4 units squared. The back side is another 6 units squared. So that is just around, let me use black. That is just what is around the entire area. But now we got to figure out what this area is, this surface area. So that's 1, 2, 3, 4. So that's 4. And then 1, 2, 3, 4, 5, 6. 6. So that this entire red is going to be 24 units squared. And that means we have to do the bottom of it too. So we have another 24 units squared. So I think that this is going to be 48 plus the green, which is going to be 6, 4, which is 10, and 6 and 4, which is 20. So it's going to be 68 units squared. And my strategy is I find the surface area of this right here. So it's just the area of that space. So it's 6 times surface area of all 6 sides. And I said, so there's 1 side, there's 2 sides, there's 3 sides, there's 4 sides, and then there's the top, and then there's the bottom. And so it's going to be 2 times the 6 plus 2 times the 4 plus 2 times the 24. All right, and you add that up, surface area. All right, so here's the 6, here's the 4, there's 2 sides of it, and then here is the 24. And we just add it all up. All right, moving on. All right, that's what I think. Let's move on to the next one. So it says, how much cardboard will it take to make each box? Drag your points to arrange the candies. If it helps with your thinking, then enter your answer here. Let's take a look at D. 6 times 4, so length is 6, width is 4, height is 1, the amount of cardboard or square units. So I said 24 in the sense of where's there we go. let's go ahead and do box D. Let's check it out. So it was 1, 2, 3, 4, 5, 6, and it was 1 up. So amount of cardboard in square units. So it would be length times width times 6 times 4 times 1. That would be actually 24. So I was incorrect, but that's okay. I'm just going to be oblivious. This one would be 24. This one was 6, 6, 12. This would be 24. And then this would be 24 and 1, and that's 24. So if I did the length times the width times the height, but that's not volume. That is actually, that's not surface area. That's actually volume. So, oh no, let's go minimize. So let's go ahead and bring up, surface area, for example. Surface area is, come on, cube. Coming up. All right. So if you look here, this is of a cube and rectangle. So it is 2 times the length times the width times the height, and the width times the height, which is what I did earlier. So that's the thing. So we're so used to looking at volume, which is length times width times height, but you got to count the squares. That's pretty much what you have to do. You have to count the squares in order to make this work. So I have 1, 2, 3, 4, 5, 6 on the side, 7, 8, 9, 10. On the back side, 11, 12, 13, 14, 15, 16. On the left side, 17, 18, 19, 20. There's 20 around. So there's 20 around. And then you got to count here. So there's 4, 8, 12, 16, 20, 24. So 24 on top and then 24 on the bottom. So that's how you figure it out. So let's go ahead and take a look at A. What would A be like? So we have 24 in length. So 24 in length. Let's use a pen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4. So that means there's 24 on the front side here. And then there's another 24 on the back side, back there. And then we have 24 on the top. And then we have 24 on the bottom. And then we have 1 here and 1 here. So that's plus 1, plus 1. All right. So again, we want to make sure that we get this right. So again, the formula was, as we said, so surface area is 2 times length times the width plus length times the height plus width times the height. And as you notice, this is my length is 24. So that means 24 times 1 plus 24 times the other one plus 1 times 1. So if you look, 24, 24. 24 times 2. 24, 24. This is 24 times 2. And then we have 1 and 1. So here's 1 times 2. So exactly what we said earlier, that's how you do it. You just want to count what's on the outside, do length times width, and cover that area. So it's just basically finding the area of anything and then just making sure that you get both sides. And that's why you do it times 2 here. All right. So, oops, I deleted it. So it was 24 plus 24. So that's 48. And then 48 plus 48 is 96. And then plus the 2 is 90, 97, 98. So this one would be 98, for example. All right. We're going to move on. That's just kind of how we run down for the surface area. I don't want to take too much time, but let me just see where we're at. 14 minutes, not too bad. Let's keep going. Next is on the screen too. You said package G uses the least cardboard. Based on what you know now, which of these packages uses the least cardboard? Okay, so we know that. Let's go ahead and do all of these right now. So this was, well, I need to go back. So sometimes you got to go back. All right. So let's go ahead and find all of these real quick. So it is, again, 2 times length times width plus length times height plus width times height. So that means it's 2. So this is 6 times 2. So that's 12. 6 times 2, 12. And then 2 times 2, which is 4. So 12, 24, 25 is 28. So 28 times 2 is 56. So this is 56. This was like 98, I believe. All right. Let's keep going. Back eraser. All right. So let's go back. Now we're going to do 12 times 1, which is 12. 12 times 2, which is 24. And then 1 times 2, which is 2. So that's 36. That's 38 times 12. I'm sorry, not times 12, times 2. That's 76. And then one more time. And then we have 6 times 4, which is 24. 6 times 1, which is 6. And then 4 times 1, which is 4. So that's 34 times 2, that's 68. So actually, I was wrong. D is 68, B is 56, and so I was incorrect. So I thought it was D, but it's actually B. So I guess it is better to have them clumped up. So if I were to make an estimated guess on how I would want to do this, I would simply just want to make sure that if I have big numbers here, that's going to cause this to go up, right? If we have big numbers, but if they are kind of evenly distributed, so 6, 2, 2 instead of, for example, 6 and 4, so the 4 is higher than everything else, right? And for the 2, that causes this to go higher. So if we had, for example, even if it was like, so instead of 6, 2, 2, say if it was like 3, or even like 4, 3, 3, maybe that would be better. Who knows? All right, moving on. Moving on to X. So based on which one is the least cardboard, it's package B. You changed your mind. Why? Because we found out it was only 56. Next. Is there a box that holds 24 candies and that uses even less cardboard? Enter the dimensions. Okay, so that's what I was thinking about. So I was thinking about making this, so instead of making it into 6, I was going to take 2 away and make it a 4, and then make this one, and then take the 2 and add 2. So, oops, sorry. So make that a 4 and make that a 3 and make that a 3. Now let's see if that works. So for example, I have 1, 2, 3, 4, and I have to go with 3. So that's 1, 2, 3, 2, 3, 2, 3, right? 2, 3, 2, 3, and then this is. So let's see how many I have. I have 1, 2, 3, 4. Oops. 5, 6, 7. Why are you doing that? 7, 8, 9, 10, 11. What is happening? 9, 10, 11. Okay, I don't know what's going on with my pen, but this is annoying. 9, 10, 11, 12, 13. No, 12. It's only 12. Oh, my height is 3. So this is the flat one. So that's 1. Let me go back to this will be better. So I wanted to do 4, 3. So that's 4, 8, 12, 24. So it's 1, 2, 3, 4 on the side, 2 atop. So that's 4, 8, 8, 12, 16, and then we'll go 24. There. So 4, 8, 12 on the side, and it goes 3 deep, so that's 12, 24. Oh, that's 36. I don't want that. Let's do that. Okay. So 4 on the side, 2 width, 3 high, because that's going to give us 12, 24 candies. So 4 length, 2 width, and 3. So 4 wide, 2 length, and 3 length. 4 length, 3 wide, 2 height. 4 wide, 3 height. I put 2 height. It should be 3 height. Sorry. Sometimes that's what you got to do. All right. So let's see what that goes like. So we have 2. Okay, now my pen doesn't want to work, so that's really annoying. All right, I guess I have to use the mouse. So let's go. We have move this up. So it's 2 times length times width, which is 8, plus length times height, which is 4, 8, 12, plus, and then 2 times 3, which is 6. So it's 20. So that's 26 times 2. So that's 52. And I think that's smaller. That's actually smaller. So I guess the key is that you want to keep these as much as a cube as possible in terms of like if they're all similar, that would be great. So maybe there's a way that we can do 3, 3, and 3. Would that make sense? 3, 6, 9, 9, 18, 27. Nope, it wouldn't make sense. But that's just one way to do it. So sometimes you have to go back and figure that out. Going on to the next one. Clear the screen. So let's go. All right, now there are 96 candies. Which of these arrangements will you use the least amount of cardboard? All right, so amount of cardboard, square unit calculated by hand, calculated with an expression. So again, if you enter an expression, press submit to calculate using the expression. So here's in your expression, use L, W, and H. So 2 parentheses, LW plus LH plus WH. That's going to be my answer. There it is. Oh, don't you love it when you have a formula? It's real life. All right. So if you look here, this is what your answers would be. And then you would want to enter each answer into the table one by one. So since the answers are already there for you, we're going to go through a couple of them. And let's see how we do. So if I did, for example, this one is 6, 2, and 8, which is 152. But this one is 4, 6, 4. See how they're more even across? It's lower. So the key is to have them 6, 4, 4. Still the same thing. So even though these had the same numbers and they're in different order, it still gives you the same result. All right. So that's one key thing you want to look at. But again, look at this high number. This is a 96 and then a 1 and a 1. Giant number. 386. So we want to, that's the difference. So volume doesn't really matter because these are all the same volume. It's just the surface area changes. All right, so let's take a look. We've got blue. Let's go ahead and do this one right here. So let's say 24 times 4 plus 24 times 1 plus 4 times 1. And then all of this is going to be times by 2. So 24 times 4 is 4, 8, 12, 16. 4, 8, 96 plus 24 plus 4. What I'm going to do is I'm going to add these two together. So that's 124 because that's 124 times 2 is 248. And that's exactly what we got. So that is how you do it with the equation. Let's keep moving forward because I don't want to keep you for too much longer. If you double the width of a box, what happens to its surface area? Well, let's take a look here. So if I can pause this, that would be great, but I can't. I would say if you double it, it more than doubles. And because I think because when you double something, you're doubling it both sides, and then you're doubling the bottom and the top too. So everything, the surface area is going to be more than double. And that's what I think. So explain your thinking. If you think it does double exactly or less than doubles, I just know that when the number goes up increasingly, it's going to increase a lot more. But let's find out what this says here. So sample responses. So one thing would be, I think the surface area will be less than double the original. This is because doubling the width is like putting two of the same sides. I think it's less than double because the front and back stay the same size. That is very true, but the other four surfaces double in area. All right, so those are some good ideas, some good sample responses. So it says that it's going to be less than, but let's try it out with our extension. So let's go to the next one. Let's train this out real quick. So if I had, for example, 4, 2, 3, get my pen. So I had 4, 2, 3, and I double my width. So that's a 4. So that would be 4, 4, and 3. Give me 1 second. What was it say? It says, if you double the width of the box, what happens to the surface area? If you double the width, well, that means the length is increasing too. So if you double the width, that means the length is increasing. Double the width, that's 4. That means the length has to increase to 8. This is doubling, but yeah, okay. I'm not gonna take too much longer because we're running out of time. Now it's 26 minutes. Yeah, so we gotta get through this. Okay. All right. Next one. What happens to things if you double all 3 dimensions? What happens to the surface area? It's just gonna boom. It definitely more than doubles. That's for sure. Give any dimensions of candies to wrap in a cardboard box. How do you determine the dimensions of the package that uses the least amount of cardboard? So given any number of candies wraps, how do you determine the dimensions of the package that uses the least amount of cardboard? Let's go ahead and take a look at sample responses, for example. So I noticed that for 24 or 96 candies, the box that used the least cardboard had dimensions that were close together. So as I said before, I think that given any number of candies, I would determine the dimensions of the box that used the least cardboard by trying to minimize the difference between the dimensions. So like 4, 4, and 4 is perfect. 4, 3, 2 is pretty good. 18, 1, and 1 is awful. This also has the effect of making the box more cube-like. Exactly. We want it to be cube-like. So those are the answers that you're looking for. All right. That's pretty much it. It's a little concept for you, a little practice. Make sure you write down that formula. Here's the formula again. 2 length times width plus length times height plus width times height. And that is your equation for surface area. All right. Have a great day, everyone. And let me know if you have any questions.